Hi, let us have a quick understanding on push and pull architecture. To get a better understanding on push and pull architecture, we need to find the difference between Flume and Kafka. Earlier we learnt about Flume, where it's going to have three components: the source, channel and sink. So within Flume, source will be connecting to the third-party application and it will be pulling the information or the data. So the third-party application should facilitate on request from the source, it should provide the required information. Very simple example, Flume will be connecting to the third-party application using the REST API and gets the response as a JSON file. And it is going to write the data into some source like HDFS. The same thing if you look at the Kafka cluster will be listening for the messages. The producer is going to produce the message and add the message into the Kafka cluster. And any message added into the Kafka cluster will be available as a part of the logical group, that is the topic. And it is the consumer's responsibility to consume the message. So with this particular understanding, if you observe very carefully, many of the use cases, we will have both Flume and Kafka working together. Let us take a small use case. Assume an organization going to do a sentiment analysis by collecting n number of comments from the social media. Let's say from Facebook, LinkedIn and Twitter. What Flume can do, it can have three agents to connect to the individual social media and harvest the information. Almost every system will be exposing the REST API. So each of the agents, they will be connecting to the individual social media and gets the information specific to a product. Flume will have a configuration on the sink. It can sync it into a Kafka topic. So I may have a Kafka topic and it can sync it into a Kafka topic. So any message that is written into the Kafka topic, it needs to be read by some other system to do the processing. So the messages, it will keep on getting written into the Kafka topic, and a third-party system or any consumer like a Spark streaming can read the data. Spark streaming, when it is reading the data, it should be in a position to leverage the Spark machine learning libraries to do the model generation and do the sentiment analysis with the model generated by the Spark ML. And it's going to write the result into some HDFS or some other storage. So this is a very good example on how the pull and push architecture going to collaborate. If you observe very carefully, Flume going to pull the information from the Facebook, LinkedIn and the Twitter social media, and it's going to sync it into some location, and a Kafka topic will be getting the messages. So the Flume has to push the data into the Kafka topic. Kafka cannot pull the data from any other third-party system, and again Spark streaming going to pull the data from the Kafka. If there are no consumer for the Kafka, whatever the message that is put into the Kafka, it will be there for the duration that have been set to be available as persistent storage. It will be available. After that, it would get discarded. So this is one example to understand the push and pull architecture. Let's understand the same thing with another use case. Assume there are n number of sensors available. Let the sensor be the sensor as a part of the mobile devices or any other units like cell phone towers, or it could be any industrial sensors. What the sensors will be doing, it will be generating the messages. Periodically, it will keep on generating the information, that is the sensor values. It will be added as a message. There are a number of APIs. It can keep on generating the message on a regular interval, say every 1 minute, and it will keep adding them into the Kafka topic. Remember, Kafka, it cannot pull the information. Someone has to post it into the Kafka as a part of some topic. Once the message gets accumulated, there has to be someone to pull the message from this Kafka topic. For better understanding, let's assume a Flume going to pull the data from this Kafka topic. You may have a question, why do I need to have a Flume? Let's justify. I'm going to bring in a data from some other storage, let us say a flat file or HDFS. But how this data is going to come from the HDFS? I may have a number of RDBMS database and I need to bring the data from the RDBMS into the HDFS. So who is going to bring the data from the database to the HDFS, that is Hadoop ecosystem, that's where the scoop comes into picture. Now, I have a requirement to consolidate the data from the Kafka topic as well as with the data which is available as a part of the HDFS. That's where Flume going to play its role of data consolidation or aggregation. Once it does the aggregation or the consolidation, it's going to write the data as a messages into some other Kafka topic. And this Kafka topic may be monitored by Spark streaming. So the data would be read by the Spark streaming, and it can leverage MLlib or whatever the processing that needs to be done. It can leverage, do the processing on the data and get the result. Once the result is available, I may have to take some action against that particular result. So what I might do, I might post that as a message into some other system or send an SMS or email, or even I might post that as a message into some other Kafka topic and the chain can continue. So if you observe over here, Flume it's acting mainly to consolidate the data from different sources, and Kafka is just acting as a messaging system to route the whatever the data that is posted into it. It's going to facilitate to get that delivered to the right consumer. If you observe any of the messaging system or any of the architecture where n number of heterogeneous system comes into picture, and especially on the big data ecosystem, we will be seeing the role of Kafka and Flume being played significantly to do the orchestration of the data.